Hey everybody. So in the section 10.1 video, we talked more about point estimates, where we can use like the sample mean to estimate the population mean. Well, if we look at this first question that I have, how likely is it that that point estimate for the population mean equals the true population mean? And if you think about that, it's probably not very likely. If we're just giving basically one guess, one estimate, how likely is it that we actually found the true population mean? Probably not likely at all. So this section, we're going to talk about interval estimation and specifically building confidence intervals. So an interval estimate defines an upper and lower boundary for an interval that will hopefully contain the population parameter. Basically, we have more options now. Instead of trying to come up with a single point estimate, now we're going to come up with an interval, a range of values that will hopefully, again, contain that population parameter. So a confidence interval is an interval estimate. I think I'm missing a word here. Maybe that or which gives an estimated range of values, which is, okay, I don't know. A confidence interval is an interval estimate that gives an estimated range of values, which is likely to include an unknown population parameter. The estimated range being calculated from a given set of sample data. And I have this little formula here. And we're going to be building these intervals, these confidence intervals. And the statistic I'm using is sample mean. And we're trying to estimate the population mean here in the middle. But once again, we're not giving one single estimate, one point estimate of sample mean. Now we're giving an interval, a range of values. And to figure that out, we take the sample mean and then we subtract an error. We call this the maximum error, which we do have a formula for. I'll introduce that in a little bit. So we have that sample mean and we subtract an error, and then we go back to that sample mean and we add that error, and we'll have some interval that is more likely to contain the population parameter compared to a single point estimate. So quick example before we get into the math, which will actually be presented in another video. So a 95% confidence interval means that if all possible samples of a given size are taken from a population, then 95% of those samples would produce intervals that capture that true mean, whereas 5% would not. And here's an example. And they have 20 samples here, and they built a confidence interval for each sample. So they basically found the mean of that sample, and they calculated an error, which we'll talk about how we calculate that shortly in the next video. And then they built an interval around that sample mean. And here they have listed out all the different, here are all the samples, all 20 samples with their intervals. And you'll notice about 19 of them actually contain the population mean here, right? And these are all in green. The intervals are a little, some of them are off, like if we look here at 7, and this one's, bigger than the rest, I guess you could say, because here's 200, here's 100. It's the same size interval, but the values are kind of shifted up a little bit more than the others. But it still contains the population mean down here, and like 15, it's shifted down a little bit, but it still contains that population mean. Sample 5 right here, however, does not. And so there was 20 samples, and we had a 95% confidence interval. That's one of the common levels for confidence intervals. You know, we could have an 80%, 85, 90, 95. Sometimes we can even go up to 99. But 95% of 20 is 19 samples. And then 5% of 20 is one sample. So for a 95% confidence interval, 95% of those samples contain that true mean, the true population mean, whereas one sample, the interval for one of those samples, probably does not. All right. There's going to be two different ways that we can calculate confidence intervals. We're going to be talking about the normal distribution as well as the t-distribution, which is something new that we haven't discussed yet. But we will talk about that in a future video. My next video will be how to actually find these confidence intervals with a normal distribution. See you then.